this area, and I think it's pretty cool. So I think Dan will show you the cleavage. But looks like to me bedding's like this. Does everybody agree? Near vertical? Near vertical, right? And then, yeah. And so you can see that as you go along this outcrop, you see a pretty substantial change in what the rocks look like. And in fact, even though this is the orientation of the beds here, once you get over here, it becomes a little hazier. Right? Right, so here we can clearly see that this is the bedding, and that's actually nice to be able to have that, because once we get over here, what happened?
It gets all cracked up.
That's right, it's fractured, right, and Dan's going to tell you how it works.
Well, just one thing about this that appears again and again, if you look at it from one angle, it's easy to be deceived as to the orientation, but if, says he, cleaner objects, you realize the eye wants to make dips so that the strike is towards you. You know, you want everything to be dipping like this. But in reality, this guy isn't. It's like that. So when you see this in an outcrop, you're not necessarily looking along strike. So that's why it's really helpful sometimes to move along and get yourself like that, and suddenly say, now I see what she's talking about. So this is the bedding. Well, you look over there, and any reasonable person could easily be excused for saying that this is it. But it isn't. That's what we have a lot of here, which is space solution cleavage. There's different ways in which rocks can strain. But one way, when you have fine grain rocks and Mother Nature is in no great rush, a good way to do it is space solution cleavage, because when you've got stress and grains are in contact and there's fluid, water, in the pore spaces, then this funky thing happens where the solubility...
I'm trying to record and you keep walking in front of my camera.
The solubility depends upon the stress. So where it's more highly stressed, of course, is at the grain contacts that are aligned with the direction of maximum, the way it wants to shorten the stress and the strain. So it preferentially dissolves along planes, a particular plane orientation, which is perpendicular to the direction the thing wants to shorten. So what we're seeing here is that in this particular case, we have a cleavage preferred shortening direction that's at a high angle to the bedding. And in some cases, that can produce things that are nice and like, okay, that's fine. But depending upon the spacing, you get what's called pencil cleavage.
Ooh!
You get stuff like that, and
yeah, I saw some of that over there. Yeah, actually.
Yeah, so you get this kind of orientation. So you got two really strong fissile planes at high angles to each other.
Yeah, I saw one spot that had a whole bunch of those pencils.
Yep.